All right, thank you, Andrew. Okay, reactive business applications. Thank you everyone for sticking around this long. I know it's been a long day. Things started very early for me in California, but everything's been very interesting. So business applications, I know it can sometimes be a curious topic to be excited about, but hopefully this will be interesting for everybody. We're going to give a quick alignment on what they are, my perspective on the status quo, why we might want to build this sort of system in a reactive way, and then we'll kind of do a deep dive in exactly how we're approaching doing that. So again, I'm not going to repeat what Andrew said, just to always drop in a brief slide, kind of describing myself. Business applications. So this is usually bespoke software that is tailored towards specific domain. This is a lot of times your internal developers working inside of companies, developing tools for individuals in the company to use day in, day out. Usage is often mandatory by everybody that's working there. Often very heavy on the data entry, and then on the flip side, they then often deal with decision support based upon that data that was entered. They're often sources of truth. And from a data volume, this is what I like to term medium-sized data. They might be dealing with enough information that it doesn't all fit in memory, but this is also not something that necessarily requires a cluster to deal with. You can generally stand up a single database server and you're cool to manage it all that way. The criticality is its importance to the business, not because it has a bunch of traffic flowing through it necessarily. This might be more of a request per minute type system. But as it is a source of truth, it's very key to the business operation itself. Let's talk a bit about how these applications are kind of built at the moment. Oftentimes there'll be a web-based UI. It might be a single-page application if it's newer. It has what I like to call a REST API in quotes here, because this is often some underspecified JSON payload delivered over HTTP. Often a relational database, very frequently accessed with an ORM on the JVM. This is properly hibernate. Depending upon how long the system has been around, the schema may or may not make a whole lot of sense. And importantly, the data is probably mutating in place. Just your very standard CRUD-based architecture of, we have the row that represents the data, and we're gonna go ahead and change it whenever the user changes it. The UI experience is probably something similar to consumer-facing apps in the mid-2000s. This is kind of before apps overtook everything. I'd like to think that was kind of a shift in the way that software was dealt with. One big change was UX became a lot more important. Once everybody started having apps on the phone, the way that you interacted with that software helped widen the audience. And there's been a lot of innovation in the browser space in order to be able to deliver these applications. Like streaming data is very feasible and possible now. There's a lot more capabilities that are built into browsers to do that. You can do background processing and web workers. The React and GraphQL have kind of changed the way that the client side has been built. And the way that you deal with getting information, not needing to refresh, getting notifications, infinite scrolling. There's a lot of capabilities that have shifted here. But they aren't necessarily being used in business applications. Part of my experience, at least with product managers, is some of these things are taken for granted because that's how a lot of software has kind of been in the consumer space for the past 10 years. This is kind of like a table stakesy feature that isn't necessarily called out, and people don't really notice it until it's missing. Also, developer experience. If you haven't been a developer that's been working in that area, you might not be aware of some of these technologies and capabilities. And for a system that's been around for a while, it might be hard to kind of bolt these capabilities on to something that you already have. So let's talk about like a different way of thinking about things that might make some of these things possible. And talking about a business system as reactive, you may not immediately jump out as like, this is the type of system that I want to build in that way, but I think there's a strong argument that the properties of reactive system are desirable when building business applications. And responsiveness is a key and straightforward one. You know, time is money, as you hear people say, and sometimes it's the difference between life and death, depending upon if it's like a very critical business system. Think 911. If you've ever been on the phone with somebody, they've had to apologize for their slow computers, you understand the value of this. But this is something that's, I think, vastly unappreciated in business applications, because as long as it works, people are forced to use it. You don't get that same like Amazon bounce where it's like, oh, latency is too high, people are going to go away. People have to stick around. But you know, having a responsive experience is valuable. Resiliency is important. You know, failure is going to happen. You know, if your business is depending upon it, you want to have a story around that. Resiliency also, you know, helps with deployments, especially if you're in a cloud-based environment. You're going to experience some sort of disruption as a matter of course. Deployments, I think, are a key one. Like, you know, your steady state of the software is maybe you have one instance of the software running. Well, what do you do when you deploy? Do you take the old one down and bring the new one back up? Well, now you have a state as if, you know, how's that different from crashing? If you bring up a new instance while the old one is still there, now you have a state when you have two instances running at the same time. And being able to handle this as part of a normal course of operation can help you in your failure scenarios, because both of those cases also kind of reflect upon ways the system can fail. Elasticity, I feel, is an advanced topic, but is one that is important for businesses. Depending upon how the business views the software, you might be, say, over provisioning resources in order to manage, you know, peaks of load. Or maybe things are under provisioned, and then you kind of suffer on the responsiveness side when things get too busy. You know, if you kind of handle elasticity in the design, then you are at least set up for the capability of using what you need, only using what you need. It's valuable, but I think this is, again, this is kind of more of an advanced topic. But message-driven is, I believe, the most important one, and we're going to be talking a lot about that. So as I was starting to think about how to put some together, there was two things that I definitely kind of wanted to do, is, again, kind of table stakes. The UI people that I'm working with, they want to do things via GraphQL. That's kind of the direction that the UI world is going towards. So we're going to do that. And again, I feel that, you know, having real-time web applications is important to kind of match the experiences people are getting elsewhere. So I wanted to make sure that I was able to utilize the subscription feature of GraphQL to kind of, you know, push data out as it changes inside of the system. Then there's a set of guiding principles that I was using as thinking about how to put things together. I feel that the system should never forget. You always want to remember, if the system learns information, let's keep it. It's a tractable thing to do. Event-driven, I found just, having discrete events flow through the system enables it to be much easier to kind of track what's going on. Kind of want to manage, read and write separation, because a lot of times you might be heavier on one than the other. So managing that can be valuable. And again, relating to failure, having some sort of story for partial availability of the system. Because again, if this is something that the business is depending upon, you do want to have it present at all times. So about remembering stuff. Storage is now cheap. It didn't used to be feasible to have a system remember all the changes that have happened to it. And one common question that I've seen throughout my career has been, why does the system have this value? Maybe that's a piece of information that somebody entered and nobody knows like exactly who put that in or where it was collected. Or maybe it's a calculation that the system is doing and users want to know, how did the system arrive at that answer? So being able to remember the information that led up to something helps answer why, which is often a key question. A way that people have kind of naively tracked history in a relational database is by having a history table. Like, I'm updating a row and I'll put a copy of that row in another table and I can kind of keep track of my changes there. If it's important enough, sometimes you'll have a table that has like 3 rows, and you'll put a timestamp on the row that says when was that row valid for, because it's a little easier to do online queries, but still it still gets complex. A key thing here is you are unifying the schema across time. That if you're ever making a schema change, you have to change the schema of your history table in order to be able to keep track of, in order to keep everything aligned. But the real problem is you've lost context of the operation that actually happened. For data that is only affecting one thing, you can probably look at before and after and kind of deduce what occurred. But if there's any more complex transformation happening to the data, it's harder to tease out what was going on. So what if we actually store the change itself? And this kind of lets the change be a message, lets the change be an event. So if we store the change, we can then just keep track of all the changes over time in a log or a ledger. And we'll materialize those into a specific schema when it comes time to read. This is event sourcing. We're gonna keep track of what happened, and then we can kind of use that to build up a view at any one specific point in time. Even if you aren't familiar with this is what your bank does. You have your bank statement that shows you each one of your individual transactions, and whenever you're going to check your balance, you're kind of viewing what that current aggregated value is. So let's store these discrete changes. We can group them together. We'll call this an event log. As it's ordered, we can now assign a sequence number to each of those, which we'll be talking about more in a bit. And if you have an existing system, you can kind of bolt this on to a degree, because a CRUD API is actually 3 very coarse events, one for create, one for update, and one for delete. I do want to say that this is not a novel idea. This is a synthesization of existing ideas. But I think the practicality or applicability of doing this has changed over time. And the reactive plumbing that is now available to us makes doing this a lot more tractable. And one thing that I helps push things in this direction is GraphQL. GraphQL encourages you to start by building your schema first, and that is really the read model to the system. And a lot of times, if you're working with somebody that is your UX designer that is helping build what the UI is, this lets you craft the read model to what the UI is, because a lot of times they might be thinking about how to interact with the system, and there's an implied model with what they're doing, but they may not call it out as much. So being able to collaborate them on the specific read schema needed is valuable. But one catch with GraphQL is that there's a very expressive type system, but that's only for the read side. So a common thing that you would see if somebody has a CRUD system that they're trying to move into GraphQL, and they're like, oh, I have my get API that gives me one payload, and I have a put or a post that puts that same thing back. GraphQL makes that difficult because the type space between the input and output types is different. You can't use the same modeling for each one. And what GraphQL wants you to do is they want you to prefer a specific mutation over a general mutation. So not having a very general update thing. If you have certain business operations that you're doing, you want to make specific mutations in order to do that. And that gives us some symmetry between GraphQL's mutations and what we want to store as events. However, an event is a desire of what has happened, whereas a mutation is a desire to have something happen. So let's talk about a mutation, and let's think of a mutation more of as a command. Commands and events are both messages, but they have a different relationship to state. A command is what I want to do, an event is what has happened. And a command may not be allowed to happen depending upon what your business rules are. And this is a concept from CQRS, the command query responsibility, where we're separating the commands from the queries. For business rules, I like to bucket them into 3 buckets. The first one is rules for data at rest that must be true at all times. This is your classic cardinality constraints, nullability, these, things that must be adhered to at all times. The next one is side effect rules. So this might be, a new customer is signed up. I want to send them a welcome email, or I've taken an order and I've ensured that my order has all the desired properties because that's the order at rest. But once a new order has been entered, I need to fulfill it. So that's kind of generating a side effect based upon something that has happened. The last bucket is what I like to think of as non-destructive transformations of data. This is display logic. Maybe you have some aggregation of data that is, again, not destructive, that you're just kind of putting together on the client side. In a strict sense, you are generating new data here, but because it is a pure derivation, we don't actually need to version our data per se. We can retain the history of that by the code that does that work itself. So for commands, we can now say a mutation is a command, and we can use a command to generate an event. Commands might end up being coarser than your events. I've found that the UI will have a desire to have a slightly coarser mutation that might do a couple of things in order to minimize the front end back end interaction. But you're still free to have much more fine-grained events that represent the multiple specific things that those commands implied. And in order to satisfy our business rules for data at rest, we are going to need to have some notion of what is the current state of the world. And we can use that by materializing our event log into some bit of state that exactly matches what's necessary for the business rules, which is likely going to be a subset of what you're using to generate your read model. If you have a constraint that customer IDs need to be unique, you only need to keep the set of customer IDs, whereas you can kind of ignore the information about, say, their name. And keep that for the read model. This lets us build a very nice processing loop. We can start with our event log. We can materialize all of those events into a bit of state. We take a command, we take that state, and we can check to see whether or not we can generate a set of events from that. If we can, according to our rules, we can update our state with those new events, and now we're ready for the next command. And I've called this loop the command processor. It can kind of exist on its own outside of any wiring to the outside world. But I find that, wiring it to the outside world in a reactive sense becomes useful. This is well suited to a actor model because we want to serialize updates to our state. We can read commands from a queue, and we can write the disposition of the command back to the queue. This gives us some location transparency as far as where this bit of code actually runs, which can kind of help if we want to think about either elasticity or resiliency. You can fail over to another host if you want, or this kind of gives you a place where you can shard your processing or partition your data. If your work is very clearly delineated by customers, you could partition your event space by customer and run separate little processing components for each one of those. Another nice side effect is this little loop is a pure function that is very amenable to testing. You can even bring property-based testing into this of, I'm going to generate some commands. I know what my I know what events to expect out, and you can sit there and iterate on that and test in isolation without worrying about having to interact with the database or any other external resources. So for the view side, in GraphQL, our GraphQL schema can define our view, and we can materialize our event log to exactly match that schema. If the needs of the user interface change over time, you can change your GraphQL schema, the read side independently, and you can just adjust your materialization. You can have multiple materializations at the same time to allow clients to slowly migrate to newer versions of the schema. As we're generating discrete events when the data changes, this is an easy hook in order to tick GraphQL subscriptions because we know when things have honestly changed. A pattern that I like to use for subscriptions is if I have a query that returns me a given entity, I have a corresponding subscription that also returns that same entity, but ticks whenever that item has changed. We can then take our event log, because in our event log, every event is sequenced. We can take that sequence number and stick it in different places in our schema to indicate when was that portion of the GraphQL structure last updated. And this can then give clients the ability to see, when did this last change? For mutations, I've deviated from the general GraphQL recommendation of returning specific answers for a mutation to returning the same answer for each one. And this is to steer the UI to use the subscriptions to drive their pages. When a mutation happens, we'll return a success. If it's a failure, we'll return an error message. That's straightforward. But on a success, we'll indicate what sequence number was the final event that mutation created. And that sequence number is then visible on the entity that we just talked about. And as the subscription ticks, you can watch for that sequence number to appear. So this is again steering the UI to, when you load a page, just use the subscription, because that will make the page one work anyway. And if the user would have the opportunity to change the data on that page, the subscription is going to be the recommended way in order to see the side effects. Internally, when we receive a mutation, we'll generate a command. We'll submit that command to a processing queue. We'll wait for that command to be processed, and then we'll return the results back to the caller, because it is still kind of a blocking operation for that from the client perspective. Internally, the entire flow is message driven, because while we receive that command, we then put it on a queue. We can have the command processor reading from the queue. It can be writing its result to a queue. It's updating the event log. We can have another listener on the event log that is updating the materialization. And once the materialization has happened, we know at what point we need to trigger that GraphQL subscription. We've also achieved the other two principles that we had talked about. Our reads and writes are separated and can be scaled independently. If we have more read traffic, we can obviously, we can spin up more nodes in a cloud-based environment and just be, reading from that same source. Or we can be materializing our information in a place that is able to support a higher level of reads, or you can really kind of tailor what the read path is relative to the write path. And because the mutation path is discrete from the query path, that also sets us up for partial availability storing. We can kind of control the blast radius of errors by kind of managing the grain with which we do command processing. Failing to do a mutation might only affect that portion of the system, while you're still able to read whatever data exists inside of the system. One of the nice properties we get is we can now track data provenance easily. All changes in the system lead back to a command. We may not necessarily want to keep commands forever. We will probably only want to keep events forever, but we can still copy as much information from the command to the event as metadata to keep track of what was going on. And another key is we're free to materialize as much history as is needed. By not throwing away any information, if future product requirements say, I want to now see different information about the past, it's now easy to do that because we have that information. We haven't lost it. It's also easy to observe the system because we are using discrete messages to track everything. We can follow those as they flow through the system. When you generate a command, that's a message. That message will beget event messages. Those event messages will beget subscription ticks, and we can follow those through as they go through the entire system. So putting it together to actually implement. So far, we've been intentionally conceptual just to kind of illustrate patterns, but how have we actually put this together? So the pieces of infrastructure that we need is we want a set of queues to manage command submission and mutation of results. We want something to act as a log or a ledger for long-term event storage. We need to materialize a view somewhere. We want some sort of pub subsystem to just drive subscriptions. And if we are operating in a multi-node environment, we might want some sort of distributed locking for, again, if we're kind of utilizing an actor model to say that there's only one instance of an actor anywhere. We at the moment are solving everything with Postgres. It has a lot of, it does everything. And for us, it helps reduce the operational overhead for the team. Advisory locks are able to use that for coordination. Postgres has a listen notify feature that can do pub sub. An append only table is a ledger. There's a separate relational schema to back the view. We can let the system, have these multiple components exist together by using database schemas to firewall. The portion of submitting a command only needs to write to the command schema. The command processor reads commands, writes events, and the materialization reads events and writes queries, writes to the query schema. So by giving different database users with different access privileges, we can control each one of these. Internally, we've wired everything together with reactive streams, and we are reactive all the way through to the database. We're built on top of Spring Boot. Netflix has invested heavily in Spring Boot. And because it has Project Reactor as part of it, and now R2DBC, we can be reactive, again, all the way down to Postgres itself. GraphQL Java is the GraphQL engine, and while not strictly reactive, it plays into this very nicely because its internal model is to use completable futures for everything. So when you're executing a query, it's very easy to bridge from Project Reactor's mono into a completable future to manage the completion of each individual node in the GraphQL structure. For subscriptions, it's even more straightforward because they've embraced the reactive stream specification. So your subscription is actually a publisher. So we can use back pressure and all the other beautiful operators that Reactive provides in order to manage, like, how do we want to deal with slicing and dicing to build that subscription stream. For watching what's going on, we're tracing with Zipkin and Brave. The Brave's the API name, but the Zipkin model, we'll have a single trace that represents an entire flow, and we'll have spans at each portion of the system to match each little chunk of work. I'm generating very wide spans, kind of in the modern observability mindset of just chunking all sorts of extra metadata tags on there to track and understand what's going on. So, in summary, so this is hopefully this has been a meaningful path to lay out to make business applications be reactive. The infrastructure and tooling is there in order to do it, and the current mindset is kind of more aligned to doing things this way. And I believe applications that are built this way will end up being more maintainable over time because the separation of concerns of keeping the events as the source of truth and then kind of dealing with them with what you want now, you're not making fixed decisions that affect the future because businesses will change, and being malleable is important. So again, I hope you're inspired to take some of those ideas back to your own work and help build more reactive business systems, even in the smaller scale. Thank you, and I'll be in the room afterwards for any questions.